Hey gang, today we are going to be talking about simplifying algebraic expressions. So let's go ahead and get started. You should have your notebooks out, and we're going to title this Simplifying Algebraic Expressions. Your essential question is, how can I simplify? How can you simplify an algebraic expression? Before we can even start about simplification, let's talk about what an algebraic expression is and all the vocabulary terms that go with it, because there's quite a few. An algebraic expression is one that has numbers and letters. Okay? Sometimes you'll see an equal sign with it, and sometimes you won't. So let's go ahead and just work on the easier one when there is no equal sign, okay? So vocabulary, we have 1, 2, 3, 4, 5 terms that we are going to be adding into our vocabulary. The first one is like terms. Like terms are terms that have the same variable, okay? A variable is letters. So all of these x's are the same variable because they're also raised to the same exponent. They're like terms. They have the same variable raised to the same exponent, okay? We also have simplest form. It's when there are no more like terms and no parentheses, okay? Coefficients. Coefficients are the numbers in front of the variable, okay? And constants are also like terms, and they are ones that have no variables, okay? So these are constants, -2 and 7 are constants, so they are like terms and we can combine them. Let's go ahead and practice this simple task first, identifying like terms. So this is when we're going to need a highlighter. So grab a highlighter, and you're going to need you're going to need to at least have 3 highlighters today. Highlighters. So pause the video, go grab some highlighters. Okay. We're going to identify the like terms. Again, like terms, if they are the same letter with the same exponent, they're a like term. If they have no letter, then they are like terms with each other. So we're looking at anything that has a y with an exponent of 1. 10 does not have a y with an exponent of 1, so it's not a like term. Now we have negative. Remember, this says negative. 3/2 y, exponent of 1. These two are like terms. Okay, second highlighter. Now I'm going to go back through my expression and find anything that is a number with no variable, and that's the only one. 10's all by itself in this one. Okay, we identified the like terms. All right, let's go to example 2. Again, you need highlighters here. Okay, we are looking for anything that has an r squared that matches up with 2r squared. So anything that has an r squared, 7r does not have an r squared. Negative r squared, like terms. These two are like terms. Okay. -9 doesn't have an r squared, so it's not a like term. Now we're going to go through and look for anything that has a 7r. 7r. Sorry, not a 7. It has just an r. Okay, -9 doesn't have an r with it, so it's not a like term. And our last one, -9, is all by itself. Okay, so we have 2 like terms here and 2 non-like terms all by themselves. 3. Looking for anything that is just a number, no variable with it. 4 has a variable. -5 is just a number, so it's a like term. P, variable, not a like term. 2q, q is a variable, not a like term. All right, let's go back through. Now I'm going to go through and look for anything that has a positive. That would be a like term with positive for p. Okay, p all by itself has the same variable, same exponent, so those are like terms. And now we're going to go look at q, and q is all by itself. There's nothing else that has a q. All right. That's how we identify like terms. Now we're going to go through and actually combine our like terms. So, problem number 4. Let's go back through and first identify. We have 14, number. Looking for anything that else has a number. This has a z, so that's not it. 8 is a number, so those two are like terms. Now let's go back through. Z, this is a negative 3z, so what's a like term with a negative 3z? Z is a like term with it. Now we're going to go through and combine them and simplify. In simplest form, we're going to combine them so that there is no parentheses and no more like terms. So to combine our two yellows, we're going to do 14 plus 8, and 14 plus 8 is 22. Now we're going to go through and combine our two pinks, and that says negative 3z plus z combined is negative 2z. Okay, so we combined our like terms. Now we're going to rewrite our expression with our terms combined. We will have 22 minus or plus 2z. So here's the two ways we could have wrote this. 22 minus 2z or 22 plus negative 2z. All right, let's go to number 5. I got to erase this. I accidentally wrote in that space. So please pause your video and write this down if you haven't, because I'm going to go through and erase this. Give myself some more room. All right, let's go through and identify first our like terms. So 2.5x, we're looking specifically x to the exponent of 1. This also has an x to the exponent of 1. So those two are like terms. And now we have a negative 5. That's all by itself. So we are going to go through and combine our two pinks. And our yellow doesn't have anything that needs to be combined, so that's perfect. 2.5x plus 4.3x is, so they have the same sign, we're just going to add them together. So let me give my room for some scratch work. 2.5 plus 4, plus 4.3. 5 plus 3 is 8. Carry down that decimal. 2 plus 4 is 6. This is 6.8x. The x tags along with them because they are like terms. And now we're just going to rewrite our algebraic expression to say 6.8x minus 5, because you still have to have that yellow there. Don't forget about that yellow. All right, 6. Let's go see if we can find our like terms. We have a 3/8b and minus a negative 3/4 b. So these are nothing but like terms. Let's go ahead and combine them. 3/8 minus 3/4. 3/8 minus 3/4. In order to subtract our fractions, we need to have the same base denominator. 3/8 minus 3 times 2 is 6. 4 times 2 is 8. Now we can go ahead and subtract the numerators. 3 minus 6 is negative 3/8. Can't simplify, but we've combined our like terms to say negative 3/8. Again, they are both b's, so I'm going to bring that b with it. All right, our last 3 examples. We are going to look at one more step when we are looking at simplifying like terms, and this is when we have our parentheses with them. Okay, when you have parentheses, you first have to remember your order of operations. Please excuse my dear Aunt Sally. Okay, we have to get rid of parentheses with the distributive property, and then we can identify our like terms. So identify like terms happens in between parentheses and exponents. Okay, so 3 times q is 3q. 3 times 1 is 3, and it's a positive because a positive times a positive is a positive. All right, let's identify those like terms. 3q, nothing else has a q. We have 2 numbers that are just numbers, no variables, so those are like terms. We have 3q. Now we're going to combine our 2 pinks together because I highlighted them in pink. Positive 3 minus 4 is a negative 1. So you can write this as minus 1, or you can write this as plus negative 1. All right. Example 8. For problem number 8, we need to undo parentheses first. So we are going to distribute out this negative 2 with multiplication. That's why I put that little dot there to remind us that's multiply. So negative 2 times g is negative 2g plus Negative 2 times 4 is negative 8. Now let's go ahead and identify our like terms. Remember, that's what we do after we get rid of the parentheses there. Let me take my highlighter out. G, number with no variable. All right, let's go ahead and combine our two pinks. Our two pinks combined together are negative 2G plus 7G, negative 2G plus 1, 2, 3, 4, 5, 6, 7 G's. Leaves us 1, 2, 3, 4, 5 G's. 5 G's. Plus, still have that negative 8, or you could have written it as 5G minus 8. Same thing. Awesome. Let's do our last example. Distributive property. Get rid of those parentheses. 7 minus, this cancels out, leaving us with negative 3x. Negative 4, remember that says negative, also cancels out and leaves us with a positive 1. All right, let's go through and identify our like terms. Number, no variable, number, no variable, and variable. All right, let's combine our two yellows. 7 plus 1 is 8, and then a negative 3x is going to leave us with plus 3x. All right, go ahead and try these on your own. Pause your video and resume when you're ready to go over your answers. Thanks for pausing that video. Here are your like terms for number 1. Here are your like terms for number 2. Here's what you should have simplified to for problem 3 and 4, and your expression you should have wrote for the perimeter for number 5. Go ahead and answer your essential question and take that checkpoint. I hope you guys are having a great weekend. Bye, guys.